Hello friends, so after discussing the set of rules for naming the coordination complexes and solving one example as we had seen in the last section based on the set of rules that we discussed for the nomenclature of the coordination complexes, now we will see a lot of examples so that we may get accustomed to the nomenclature system for the coordination complexes. So let's just see the first example as I have written here, K3Al C2O4 whole thrice. So the first step for the nomenclature of these coordination complexes is just to identify that what kind of a coordination sphere it is and what kind of a compound it is. So as you can see, there is potassium outside the square brackets, outside the coordination sphere, and this is the coordination sphere here, AlC2O4 whole thrice. So potassium is the positive part, so because it will be dissociated as K plus, so this is the positive part. That means what it implies, the coordination sphere is negative, right? Okay, the entire coordination sphere is negative. So after that, when we enter the coordination sphere, then what we have to do, we have to name the ligand first, right? So which one is the ligand? So C2O4 whole thrice, that is the oxalate ion is the ligand. But before that, the rule number 1 says that while we name the ionic coordination complex, so this is an ionic coordination complex, the positive part is named first, the cationic part, and then the anionic part. So if you see this carefully, the positive part is the potassium, which is outside the coordination sphere. So that is why this potassium will be named first. So the name will start with the positive part, that is potassium, right? Potassium will be named as such. Then after that we will enter the negative sphere, that is the coordination sphere. So negative sphere, first of all we will name the ligand. What is the ligand here? This is oxalate, C2O4 oxalate, which is 3 in number. Okay. So potassium, so we will write tri or tris also we can write. So we can write trioxalate also or trisoxalate also. Trioxalate, right? And then one more rule that we had discussed previously, that if the central metal atom, here the central metal ion is the aluminium. So if that is in the negative coordination sphere, then that will end as ATE, right? The suffix will be ATE. So since it is in the negative coordination sphere, so it will be named as aluminate, right? Aluminate. After this, what we have to write? We have to write the oxidation state of the central metal ion. So let's just calculate it quickly, the oxidation state of the central metal ion. So this is potassium, so plus 1 charge, so 3 times potassium, that is plus 3 potassium, so plus 3, plus aluminium, let's keep it as X, the unknown one, plus oxalate, just like sulfate, oxalate charge is also minus 2, right? So C2O4 is minus 2, just like sulfate. So that is 2 negative charge, so it will become what? So it should be, so 3 times minus 2 is equal to 0. So x plus 3 minus 6 is equal to 0. So x is equal to plus 3. So that means aluminium has plus 3 oxidation state. So we will write that in the brackets like this, 1, 2, 3 in Roman numbers. So it becomes potassium trioxalate aluminate, right? So this is how we will write the name of this complex. Okay, now let us move on to the next example. Okay, now I have written this second example here. So as you can see, what is the second example? The second example is KPtCl5NH3. So this is our second example. So this part, the potassium part, is positive, and within the coordination sphere this is negative. The first coordination sphere is negative, again just like the first example. So we have to follow the same technique or the same pattern of writing. So what we will write first, we will write the, in the ionic coordination complex, we will write the name of the positive segment first. So the name will start with potassium again, right? After that, we move on to the coordination sphere, which is negative, and within the coordination sphere we have to write the name of the ligands first. Ligands in alphabetical order. We have these 5 chlorine ions, so it will be chloro, and then we have amine, ammonia ligand, so amine. So amine will be written first, followed by the chloro. Okay, so potassium, then we will write amine, double M, amine. Then after that, how many chlorine as ligands, chloride ions? So 5. So it will become pentachloro, right? Pentachloro. And then after that, the name of the central metal ion, since it is platinum, and platinum is within the negative coordination sphere, so that is why it will end in ate, ate, right? So it will become, from platinum it will become platinate. So pentachloroplatinate, right? So platinate. And lastly, the oxidation state of platinum. So let's calculate it quickly, the oxidation state of platinum. So just keeping platinum as X, we can calculate here. So potassium will be +1 plus X, chlorine, 5 chlorine ions, chlorine contains -1 charge, so 5 chlorine ions will be -5. Amine, that is 0, is equal to, so amine has no charge, so it will become 0, so equal to this, X is equal to +4. So what is the oxidation state of platinum? That is 4. In Roman numerals we will write like this. Okay, so it becomes potassium amine pentachloroplatinate. Okay, now let's move on to the third example. Okay, so I have written this third example, CaFeCN6, right? This is the third example. So just we have to identify what the positive and the negative part of the coordination sphere. So calcium, so it is positively charged, right? Ca plus 2 plus, so okay, and then this one automatically is the negative part of the coordination sphere. Okay, now we will as usual name the positive part first. So the nomenclature starts with calcium. Okay, then after that, when we enter the negative part of the coordination sphere, we will name the ligands first. So which one is the ligand? The cyanide. So cyano. So how many cyano? So it is hexacyano, 6 cyano, so calcium hexacyano, right? And then after that, we will write the name of the central metal ion. Since it is in the negative sphere, it will end in ate. So ferrous becomes ferrate, right? So cyanoferrate, correct? And then the oxidation state within the brackets as Roman numbers. So what is the oxidation state of iron here? Calcium is +2, iron is +X, cyanide has -1 charge, so 6 cyanide ions means -6 is equal to 0. So X becomes what? So X becomes -2 plus 6 becomes +4 here. So 4. So in Roman numbers we will write cyanoferrate 4. So calcium hexacyanoferrate 4 is the name of this complex. The example 3, the third example. Okay. So hope you are able to understand and follow this, the nomenclature, how to identify the ions and how to identify the positive and negative part of the coordination sphere, and then how to proceed. So first naming the positive part of the coordination sphere and then moving on to the negative part. If the negative part is the principal first coordination sphere, so within that coordination sphere we have to name the the ligands first in alphabetical order, followed by the central metal ion and with the oxidation state of the central metal ion within the brackets. Okay, now let's move on to the next example. Okay, so this is our next example that you are able to see now, the fourth one, FeH2O whole 6 SO4. Okay, now let us identify which one is the positive and the negative. So sulfate, so you know this, so sulfate is the negative part of the coordination sphere. and then this first coordination sphere is the positive part, within the brackets is the positive part, because sulfate is the negative part. So like that we can identify. Okay, now we will, since here the positive part is within the square brackets, the coordination sphere, so we will name the square brackets first. So the nomenclature within the square brackets will start with the nomenclature of the ligand. So what is the ligand? The ligand is water. So in the previous sections we had seen that water is named as aqua, right? That's an exceptional nomenclature for the ligand. So how many water molecules? So 6. So we will write hexa aqua, right? Hexa aqua. Okay, after that what we will write? The name of the central metal. So since it is positive, so it will be named as such, hexa aqua iron, right? Iron oxidation state within the brackets, and lastly the name will end with sulfate. So let's just quickly calculate the oxidation state of iron here. So let's take it as X. The oxidation state H2O is neutral, so it will be 0. Sulfate is -2 charge, so -2 is equal to 0. So it will be X is equal to +2. That means the oxidation state of iron in this complex is 2. So we will write 2 in Roman numbers like this. So the name of this complex, example number 4, becomes hexa aqua iron 2 sulfate, right? Hexa aqua iron 2 sulfate. Okay, so hope this is clear, and one more example we'll discuss here. So this is our fifth example, NaAuCN whole twice. Okay, now let's just identify what's the positive and negative part of the coordination sphere. So sodium is the positive part, okay. AuCN whole twice is the negative part, so we will name the positive first. So the nomenclature will start with sodium, right? So sodium. After that we'll move on to the negative coordination sphere, that is AuCN whole twice, and within the negative coordination sphere the ligand is cyano. So how many cyanide ions? So 2. So it will become dicyano, right? Dicyano, and this is Au is gold, so it becomes, since it is within the negative coordination sphere, so it should end in ATE8. So it becomes sodium dicyanoaurate, right? AURATE, aurate. So sodium dicyanoaurate, okay. And lastly the oxidation state of gold here. So let us just quickly calculate the oxidation state of gold. So it's easy. So sodium is +1, gold is +6, cyano contains -1 charge, so 2 cyano ions, so -2 is equal to 0, okay. And then finally X comes out to be +1. So gold has a oxidation state of +1, so we will write it in the Roman numbers 1. The name of this complex becomes sodium dicyanoaurate. So hope this is clear. We will again see another set of examples, so that we may be very accustomed and very free with naming these coordination complexes. So we'll, in the next section again, we will deal with several other examples. So hope this set is clear, and hope it helps. Thank you.